Hi gang, welcome to another video. What we're going to have a look at today is calculating what's happening here in relation to frictional resistance. Alright, so when we talk about frictional resistance, we're talking about the friction acting between two objects that's causing some lack of movement or increased movement. Alright, now as always we need to have a little think about what's going on here, so I'll give you a moment just to work out what's happening. I'll read the question and then we'll see if we can solve it together. Okay, so we've got this very small person here pushing this object on an inclined plane. That object has a mass, which you've got over here, and it also is got an angle, which we'll come back to in a moment. So what we're trying to work out here is what resistance is this object have in place when we're trying to move it. Okay, now let's have a look at our formula sheet. So if we have a look at our formula sheet here, there's actually three different formulas we're going to need to use. We're going to need to use this one, which is our bog standard force equals mass times acceleration, or force equals mass times gravity. We're going to need to use the component of the force for the horizontal direction. We're also going to need to use the frictional resistance force, which is this one here. Okay, so let's go ahead. Let's see if we can come up with a solution to this. Now, if you have a look at your formula sheet again, you'll see that the force is equal to mass times acceleration. Okay. Now, what we need to do is forget about acceleration for now, because there's no actual acceleration value here other than that of gravity. Okay. Now, because we've got a force acting at an angle, we need to find out what's happening along this horizontal plane. So in actual fact, we're going to need the cos theta. Alright, so we've got fx, it's the horizontal, because we're pushing this in the horizontal direction even though we're going up a hill. So what we're going to do is we're going to pop some values in here. So we've got the mass, which is 8, we're going to multiply that by 9.81. Again, check your formula sheet if you can't remember where we got that g from, and we're going to do cos the angle, which in this case is 30. Now this, you could change that to 25, 26, whatever the value is that you can come up with, and it's the same technique that we're going to come up with here. Okay, so this force in this x-axis is equal to 67.97 newtons. Alright, now that's what we'll call the normal force. Okay, now that big capital N is the normal force, so that's 67.97 newtons. Okay, now the reason I'm putting that capital N there is because if we go back to our formula sheet, we can see to calculate the force to overcome friction, we need this formula here. Okay, now that N is what we've just calculated, but that funny little looking U thing is actually the symbol we use to represent coefficient of friction. And if you have a look on here, coefficient of friction, the inclined plane is 0.4. So when we go ahead and we try and solve this to find out what the force to overcome friction is, and we'll put little r next to that to represent resistance. Yeah, we're going to take the coefficient of friction and we're going to multiply it by a normal force. Now that coefficient of friction doesn't have any units, so when we get our answer, our frictional force is going to be in newtons. And don't forget, there are other videos on showing you how to apply that coefficient of friction calculation, and it does explain in there why there's no units for that. Really, it's a ratio over two forces, so they would cancel each other out. So in this case, we're going to do 0.4 times 67.97, and that will equal, stick that on your calculator, 27.2 newtons. Okay, so that is our frictional force. Alright, so that's the force required to overcome friction. So really what we're saying here is to get this object to move up in this direction, we're going to need to apply that force to overcome that friction, which will get that object moving. Okay, so we're going to do 27.2 newtons in that case. So double underline that to get that one. Now you notice, the observant wants amongst you, there's actually a second part to this question. So step 1 method of reducing friction within an engineering system. There's several answers to this. You could have lubrication is one of them. Yeah, if you apply some kind of oil or grease, then that's going to be, help reduce friction. You could look at changing the materials. Alright, so to give you a different coefficient of friction, you could change the materials in that system, which would obviously either reduce or increase depending on what materials you selected. Others, if you put some wheels on that, obviously that would reduce the amount of frictional resistance as well. So there are a number of other answers to that question. But hopefully that makes sense to you. But again, there are video tutorials on these subjects already, so if you want to go back and go through those then before you start working over these. And as always, have a play around, change the numbers. Repetition is key when it comes to solving these problems. So enjoy and have a good one. Speak to you soon. Bye bye.